Hello friends, in this video we are going to discuss about the colligative properties. So let us start. Learning outcomes. So you will be able to know about the colligative properties: relative lowering of vapor pressure, elevation in boiling point, depression in freezing point. Osmotic pressure we will discuss in the next video, and related numerical on all these colligative properties. So what do you mean by colligative properties? The properties that depend only on the concentration or number of solute particle and not on the identity or nature of solute particle. If the property depends on only on the number of solute particles and not on the nature of the solute particle, that are known as colligative properties. Examples are lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. Osmotic pressure will take up next. So what are the formulas related to that? We will discuss that. P0 minus Ps divided by P0 is equal to mole fraction of solute. Elevation in boiling point is delta Tb is equal to Kb into m. Freezing point depression is delta Tf is equal to Kf into m. Osmotic pressure P of pi is equal to CRT, where C is concentration, R is gas constant, T is temperature in Kelvin. And above boiling point elevation and freezing point, M represent the molality. So now you can see that examples of colligative property we have discussed already. These are four basic colligative properties: lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. Now let us start with the first one, relative lowering of vapor pressure. What is mean by? So if you see the pure solvent, let us see the left hand side, this is the pure solvent, and when you added solute here, so what is happened? Here is, if you see the molecules here, molecules are less. It means exerts lesser vapor pressure. It means that when you add solute in a solvent, the vapor pressure will decrease because some of the surface area will be occupied by this solute molecules. So that's why the vapor pressure decreases when you are adding solute. This is the meaning. The vapor pressure is lowered. So that is known as lowering of vapor pressure. Relative lowering means this lowering and divided by this actual vapor pressure of the solvent, that is known as relative lowering of vapor pressure. So let us discuss next one. So Pa0, this is vapor pressure of pure solvent, and Pa is what? Vapor pressure of solution. It means Pa0 will always be more and Pa will be less. So this lowering is known as lowering, and if you divide by the maximum, this is known as relative lowering. And it depends on what? It depends on mole fraction. Mole fraction of what? Wb by Mb. This is moles of B. So moles of B divided by total moles. This is known as mole fraction of solute. So if you see here, it is easy to understand here. P0 means relative lowering of vapor pressure. P0 minus Ps divided by P0 is equal to mole fraction of solute. P0 is what? Vapor pressure of pure solvent. Ps is what? Vapor pressure of solution. And always P0 will be more, Ps will be less. So this will be a positive. So relative lowering, this first is lowering divided by P0 means relative lowering. Relative lowering of vapor pressure depends on what? X of solute. Solute means what? It is representing here B. You can write 2 also. It depends. You should understand that what is the meaning. Mole fraction of solute. Whether A or B, that doesn't matter. B normally you are taking usually. Or 2 we are taking usually. Okay, next. Let us understand this by one numerical. So now read it. Vapor pressure of water at 298 Kelvin is 23.75 millimeter of mercury. So this is vapor pressure of water. What means pure solvent? It is P0. Calculate the vapor pressure of at the same temperature over 5% aqueous solution. Now we have to calculate Ps. Now from the very question, we should know that whatever the answer will be coming, that will be less than this, because P0 is this, Ps is this. Ps, you see, this is answer is 23.37, which is concurrence with our theoretical aspects. Now 5% aqueous solution means what? 5% aqueous solution means 5 gram of urea in 100 gram of solution. So let us say how to do that. P0 is given, Ps we have to find out. 5% means 5 gram. 5 gram you have to calculate moles. 5 divided by 60, that is molecular weight. So moles divided by total moles. So 5 gram means 95 gram is water. 95 by 18 are moles. So we have solved it from this formula. P0 minus Ps divided by P0 is equal to mole fraction of solute. Solute is was what? Urea. 5%. 5 by 60. 5 by 60 plus 90. Number of moles divided by total moles. So hopefully you have understood that. Now my question to you is, now you have to do yourself. You can pause the video here and just do it. Okay, because after that you match your answer whether you have understood the concept or not. So please see that. Okay, I will pause for a few seconds, but I will continue that. You can pause the video. Okay. Now in this, what is given? Mass of non-volatile solute that we have to find. That means W we have to find. Molar mass is given, which should be dissolved in 114 gram of octane to reduce. Octane is a solvent. To reduce the vapor pressure 80%. 80% means earlier if it is 100, then it is 80 now. So this is the meaning. So if I take the mass of solvent is this given, molecular mass is given, and for the octane, this is the solvent. This was solute, this is solvent. Solvent molecular mass we can calculate, that is come out to be 114. So now this is the formula to be used. If 100 is the previous vapor pressure of solvent and 80% means 80, divide 100 minus 80 by 100, that is a relative lowering of vapor pressure depends on solute, mole fraction of solute, moles W by 40. This is the molecular mass given, and this I have taken 0. Why? Because if the solute, if you go back to the video, just check it here. If you take it there, if concentration is dilute, WA is very very large or solute is very very less, then we can make it 0 here. We can make it 0. That is the reason that I have made there 0. Just see. So in this I have made it 0. Why? Because I have thought that mass solute, this solute W by 40 is very very less as compared to that of 1. That is the reason. Okay, so after solving this, it is 8 gram. It will be helpful that why? Because it's easy to calculate. Otherwise you can substitute W by 40 and solve it. You will not find any much difference. You can do yourself also, like W by 40 you fill here also and then solve these equations. After solving you will get the answer near to 8 gram, not more than or less than that. Okay, so if you have solved this correct answer, you can clap for you. It means you have understood the question and the concept. Now the next colligative property is elevation in boiling point. So we have understood the formula delta TB is equal to KB into M into I. What is delta TB? Delta TB is TB naught minus TB. TB minus TB naught. So TB is more and TB naught is less. What is naught represent the standard? Standard means solvent. Solvent boiling point means if water is there, boiling point is 100 degrees Celsius. Now here the concept is elevation. Elevation means increase. Now you just take the solution as a water, first water and urea solution is there. Let us say first water was there. Water you just heating the water. What is happening? The vapors are formed. So the vapors, the temperature at which the vapor pressure is exerted on the walls of the container is equal to atmospheric pressure. That temperature is known as boiling point. That is the definition of boiling point. Now what has happened that if we are taking pure solvent at normal atmospheric pressure, that boiling point is 100 degrees Celsius. That we know. That is a standard state. That's why it's written 0 there. TB naught. That is 100 degrees Celsius. But if you add urea to that, or if you add sugar to that, or you add any non-volatile solute, what is going to happen? The boiling point will increase. If boiling points are increasing, just what is happening? TB is more than TB naught. So it means that the elevation in boiling point is represented by delta TB, and that is proportional to M. M is what? Molality, and KB is what? Constant of proportionality, and it is also known as molar boiling point constant. It is also known as molar elevation constant. Okay, or immunoscopic constant. Sometimes the question is coming, define molar elevation constant. So if you are delta TB is 1, molality is 1. So if molality is 1, delta TB is equal to KB. I factor we will take up later. You just take I as 1 because that is at the end of the chapter it will come. Delta TB is equal to KB into M. That's much formula, you just take it into account. So now if M is 1, molality is 1. So what will happen? Delta TB is equal to KB. So it means molar elevation constant is equal to elevation in boiling point when 1 mole of solute is dissolved in 1 kg of solvent. So this is why this is how we can define the molar elevation constant. I will repeat once more. It is elevation in boiling point when molality or number of moles of solute dissolved in 1 kg of solvent. So unity, molality is unity. Next, so KB depends on certain factor like TB square, and these are delta HB. So normally this is not being asked, but you should know the relationship. Elevation of boiling point depends on the square of the temperature of boiling point. Now the curves. Now you see from the curves what is there. This is the curve between vapor pressure and temperature. Now in this, if you take TB naught and TB naught take it this and solvent, that is atmospheric pressure. It means the pressure exerted by the solvent molecules when equal to atmospheric pressure, that is known as boiling point. Now what happens when solution is there, that temperature, the pressure is now at equal only at what point? At TB. So this TB is more than that of TB naught. This elevation is known as elevation, this increase is known as elevation in boiling point. Okay. So now let us understand this concept by using numerical. Now here what is given? Glucose is added in a water. Water is a solvent, glucose is a solute. What temperature the water will boil? It means what you have to find? You have to find TB, not TB naught, and you know that TB must be greater than TB naught. Now if you take TB naught, what could be the TB naught at the standard pressure? 1.013 bar. It would be what? It would be 0. It would be 100 degrees Celsius. 100. If you convert into Kelvin, that would be 373.15. And now you see the answer. The answer is more. It means TB naught will be less and TB will be always more. This is the basic thing you need to keep in mind while solving any numerical. So okay, let us start. The TB, it is not given, but you should take by yourself. At standard it is 100 degrees Celsius or 100 or 373.15. We are added 273.15. Sometimes in the book they have solved by using 273. That is also right. It's not wrong. Little bit variation will come in the answer, but that is acceptable. Now glucose we have added how much? 18 gram, and you know you can calculate the mass of molecular mass of glucose. That will be coming 180 gram per mole. Mass of solvent is 1 kg was given. You have to convert into gram. And now you can substitute this formula delta TB is equal to Kb into m, where m was molality. For molality you can write this further formula, that is W2. W2 is mass of solute divided by M2. M2 is molecular mass of solute. W1 is mass of solvent multiplied by 1000. After substituting these values in this formula, you will get the answer for TB, that is equal to 373.098 Kelvin. So now you can see that this should be more little bit. You can check the answer, or might be a little bit of variation in the answer. It would be always coming a little bit more than that of that 373.15. Please check it once more. This answer might be a little bit variation would be there. So this answer will be greater than this 373.15. Please check it once more. Okay. Now let us try this question yourself. So you pause the video here and do yourself. And let us check whether you are getting the right answer or not. So in this problem, you just see the boiling point of benzene. It means TB naught is given to you and 1.8 gram. This is W2 and dissolved in 90 gram. This is W1 and TB is more. TB naught is less. Okay, and molecular mass we have to find out. Kb is given. Fine. So this way we can solve that. TB naught is given, TB is given, W2, W1 is given. We have to find molar mass. Kb for benzene is given. So delta TB is equal to Kb into M. M is this W2 by M2, W1 1000. After substituting, you will get the answer 58 gram per mole. Molecular mass, it's not gram, it is gram per mole. Sometimes in books also written this gram. It's not actually gram, it is gram per mole. Okay. So if you have got the right answer, it means you have understood the concept. Okay. Next is depression freezing point. So earlier we have discussed about the two colligative properties, and I would like to remind you that the colligative property depends on the nature of, depends on the number of solute particles and not on the nature of the solute particles. Okay. So not delta TF. Delta TF is change in freezing point. It means freezing point previously it was different and now it is different after adding solute. Similarly, is equal to Kf into M. I you just ignore, you just write the formula delta TF equal to Kf into M. Okay, and what is delta TF? TF naught. TF naught means standard state. Standard state means 0 degrees Celsius. Freezing point of pure solvent, that is water. Okay, and TF would be, what would be? It would be less. Less means if it is 0 and the freezing point might be -2. So 0 minus 2 is equal to 2. So delta T always will be positive. Please do remember that. And Kf molar freezing point constant, that is given 1.86 and units is degree Celsius per molality. Okay, so sometimes question is coming, define that molar freezing point constant or molar depression constant. How you have to prove this? You can put m is equal to 1. So it say the molar depression constant is equal to depression in freezing point when 1 mole of solute is dissolved in 1 kg of solvent. Okay, or when molality is unity. This way also we can tell. And units also they can ask you, you know that this is in Celsius or Kelvin. Kelvin divided by M. M means molality. This is the units for that. Celsius per unit M or moles per kg we can write instead of M. Okay, so similarly Kf depends on the second power of the T temperature. Okay, fine. Next is the graph. Now you see from the graph vapor pressure and the temperature of the solution and T. Now you see what is there. So now it is solvent here. Solvent, then it is vapor pressure of that solvent at that particular temperature. 0 degrees Celsius will be the atmospheric level. So if it is, so what will be there? So this would be 0. And now if you add solute and that particular solution is formed, that the freezing point is now decreased. Earlier, for example, it is freezing at 0. Now it might be freezing at -1. So that the difference is 0 of -1, that will be +1. So this delta TF represent the value +1 or plus, always it will be positive. It will be change in the freezing point. You know the freezing point, if it is 0, if it changes to -1, it will be 1. And if it is 0 and that changes to -2, then it will be 2. If 0 is there, then it changes to -5, then it will be +5. Okay, whether Celsius or Kelvin doesn't matter. Now here what you observe? We can see here that roads are cleaned, snow is not there on the roads. Why? So this is the question. So what they are doing? They are spraying some powder. That powder is known as de-icing agent, and the sodium chloride is used. So it means sodium chloride, what happens? What it is doing? Sodium chloride depresses the freezing point. Earlier, for example, freezing takes place at 0 degrees Celsius. Now it might not be taking place even at -5, -7. So that's why they are spraying the sodium chloride, that is acting as a de-icing agent, or it depresses the freezing point of the substance or the water, freezing point of water or solvent or solution. Now this one more thing is there, antifreeze. Glycerol is used in the car radiators. If you see the car radiators, if you are going to hilly areas, the water in the radiators may freeze. So to prevent it from freezing, we are using antifreeze. Antifreeze what is the same thing. It depresses the freezing point. For example, if you are a very cold countries like -10, -12, -15, this much temperature is there. So they are adding antifreeze in the radiators. Moreover, ethylene glycol is also used as antifreeze or antifreeze. Better we can write de-icing because it is very costly. So de-icing only sodium chloride is used, and ethylene glycol is used as antifreeze. Now let us do the numerical on this colligative property. 45 gram ethylene glycol is mixed with 600 grams. So it is solute, it is solvent. And freezing point depression, it means delta TF you have to calculate in the freezing point of the solution. We know we can solve that. It's an easy question. Let us see how. So delta TF is equal to Kf into m. Okay. So delta TF 45 gram W2 and molecular mass we have to calculate. By using this, you should know the formula and substitute and get the answer. Because carbon is 12, hydrogen 1, oxygen is 16. You can solve, you will get answer 62. And W1 is 600 gram of water. And delta TF is equal to T0 minus TF. So this T0 will be, let us say 0 and then minus of minus. So this will be the name. If 0 is there, or 273.15. So this way we have filled 273.15, we got 270.9. So it means this is more, this is less. If you change it to Celsius, it would be 0, it would be negative. Okay, so this is the answer. This is a simple problem. Simply substitution of the, so the way of the writing the question is very important. You have to write whatever is given quantity, what is the formula used, and then you have to substitute and get the answer with the unit. Now this question you can pause the video and do yourself, then only you can see that you have understood the concept. So okay, let us start now. 1 gram of non-electrolyte solute dissolved in 50 gram of benzene lowers the freezing point of benzene by 0.40. Freezing point depression constant for benzene is 5.12. So this is self-explanatory. If you solve it, you will get this answer. It's not a typical problem. Now you have understood that when you add solute in a solvent, elevation in boiling point takes place or boiling point increases, and when you are adding solute in a solvent, pure solvent, the freezing point will decrease. Okay. Now let us recap whatever we have learned so far. So colligative property depends on the number of solute particle and not on the nature of solute particle. That is one. Relative lowering of vapor pressure, elevation in boiling point, depression in freezing point is a colligative property, along with osmotic pressure that we will take up in the next video. Standard vapor pressure for water is 760 mm of mercury. Boiling point at 1 atmosphere pressure is 100 degrees Celsius, and freezing point is 0 degrees Celsius. You can convert it to Kelvin by adding 273 or 273.15. Elevation in boiling point, please do remember this point, TB will always be greater than TB0, and similarly depression in freezing point, TF will be always more negative than TF0. So 0 or -2, which is more? 0 is more. Okay, so these are the things which we have discussed so far. So now assignment for you is you should read the topic thoroughly from the book and practice the numericals from the assignment and review exercise, and as well as from the board questions. So okay, so this was the problem. You can do yourself. This is a practice problem on Raoults law. Previous video we have discussed the typical questions from the Raoults law. This is easiest question from the Raoults law. So if you are able to solve this correct answer, it means you have understood that concept also. Okay. So thank you very much for your patient listening and watching. So okay, bye.